Right, let's get back to the tools, the hand tools. Now I want to emphasise the term square. Now, square is an element in building of anything, whether it's a house or a piece of furniture, that means 90 degrees, no less, no more. It means spot on 90 degrees, or a quarter circle. Now there are certain tools that we use. Now the carpenter, because he does bigger jobs like rooms and things like that and doorways, he will use what they call a carpenter's or a roofing square. Now this one's just a plain carpenter's square, not a roofing square, because it had different angles on it, the other one. So it's got centimetres on one side, or millimetres again, or it's got inches on the other side. So it's a combination tool that can do imperial and metric measurements. So that gives you a nice square corner. So if I were to put that on my bench here, line it up with the edges, I can tell this corner here is perfectly 90 degrees, so we don't get any mishaps. Now the problem is with square is that it sets the pace or the quality for every job. Now if a room is not square, then you'll have the carpet layers cursing you. If a kitchen room is not square, you'll have the cabinet makers cursing you, because the walls are out. So they're either less than 90 or more than 90 degrees. And when a kitchen is built, it is always 90 degrees. So it's set up in the factory at 90 degrees because all the carcasses, all the cupboards are cut at 90 degrees. So you put that together and then you bring the whole kitchen into the room, and you find that 3 metres along the wall, there's that much gap between the wall and the last carcass, or the last cabinet, or the other way around. You put the kitchen in the corner, and in the corner, there's that much gap on the first cabinet. Now that's a problem, because then you have to compromise by moving the kitchen forward and putting in some blocks or some fillers so that you can screw the cabinets to the walls. Now that's a lot of hassle, and it's not fair to the cabinet makers because they make everything to a price. I built a kitchen one day at Brunswick Heads in New South Wales for a mate of mine who owned a unit. He had the unit stripped because it needed maintenance. He had it totally stripped right down to the bare walls. And he said, right, I need a kitchen this size, that size. He gave me the plan. I said, right, I'll get to it. A week later, when I went back to fit the kitchen, I couldn't believe my eyes. Now, this is called a spirit level. I'll just use that for this demonstration. When I put my level against the wall and looked at the bubble up here, the wall was perfectly plumb or upright or perpendicular. I thought, no, this can't be right, I'm in Australia. I put my level against the wall, dead straight. I thought, no, I'm dreaming. This doesn't happen here. I put my roofing square, or in this case my cabinet square, into the corner. What? That lines up with the square. I couldn't believe my eyes that the actual room was square and straight. And when I installed my kitchen, it consisted, I think, of about 12 different cabinets. I had that done in 2 hours because everything was straight and square and plumb. So, when you get things that are made correctly, you don't have any problems. If a room, like I said, in a house is not square, you will have the carpet layers finding that there will be, say, 50 mil short of the wall, and over here it touches the skirting board, so we've got to cut an extra 100 mil off to accommodate the wall that's out. Another thing too that is a great problem, when framers have finished and they've built the frame for the doorway, it is my job as a carpenter joiner, or a fix-out chippy as we call them. Chippy is a slang word for carpenter. When I do that, like when I go and put a doorway in or a door jamb in, I always use this. I think, the door head's out of level, right? The corner's not square. I'm going to have to build my door jamb, which is, I'll just use this here. Right, you got the wall, the top plate, the floor. You got the last stud right there, and then the door head is there. Right, now if that angle is less or plus 90 degrees, something's got to be out. The corners have to be perfectly square. When I draw it that way, that means it's 90 degrees spot on. If I do that with a radius on it, it means less or plus any angle, and that causes problems. So what I have to do, I have to build my door jamb separately, making sure both corners are square, and then have to fit it in to the actual opening, and then make sure that what they call the stiles or the uprights are perfectly plumb, meaning perfectly upright, and the top has to be perfectly level. So the doorways are not always square and level, and that's because the job has to be done quickly because everybody's on contract. So I build my door jamb and I fix it to the wall, to the frame. Now I've assessed with my spirit level that this stud here, or this upright, is perfectly plumb, meaning straight up and down. So I fix this stud to there, screw it in, and then the door head and the other stile, they are loose. So I leave them loose for the simple reason that when I swing the door off the stile that has the hinges, when I close the door, like here, if I were to close the door off the hinges, I can adjust the door head and the stile to suit the door. Doors always come perfectly square. They're manufactured square. That means they've got 4 square corners. And when you have to swing a door into an opening that isn't square, you've got a lot of extra work. Meaning you have to plane the door down, you have to plane the door head down, and that causes a lot of problems, a lot of frustration. So what we do, we screw the door on the stile that is perfectly plumb, and then we move the head and the other stile to suit the door before we screw it in. And then if the doorway is out, we have to apply or install what they call packers, bits of offcut that are 3mm, 6mm thick, that you have to put in between the door jamb and the frame. So putting a door in correctly and swiftly all depends on the workmanship and the skill and the care of the carpenter who built the house frame. And that's not always the case. They just go bang, 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 and they walk out. For them, the job's finished. But then for us to come in and do the doorways, the skirting, the staircases, the kitchen, the built-ins, the robes, and the doors, we're going to have to now put up with the lack of quality or integrity that the previous crew have left behind. And that's one thing that we always are concerned about when we go on a job site where the house is finished. That is, if the frame's done, the roof's on, the windows are in, and the plasterers are gone, and we come in to do the rest. So we go in with fear and trembling, if you like, hoping that they get their doorways right. Because a lot of workmanship is not done with pride, it is done with speed. And that's the difference in many so-called trades today. It's quick, get it done quick, grab your money and run. And that's what we need to re-establish, is quality workmanship, integrity in the building, and then we can enjoy the pride that we have in our finished product. Now, the old standard square for a cabinet maker of, say, my era was just the wooden square with a steel blade, and they used to put fancy brass in there and a brass lining. That's a fixed square, and it's used for just squaring things up. You put that on the edge and then just draw a line, and this corner is perfectly square, as in 90 degrees. Now, the other one that we use as chippies or tradies is what they call a combination square. It has a blade in it that you can move through the actual body and can lock in at any position. Now, if you have a narrow piece of wood, you can bring it back, line it up and put your mark through there. So that corner's square. If you have a larger piece, well, you can adjust the blade to suit. Also, if you need to draw a parallel line along the edge of something, you set the distance, let's say 60 mil. That's not a bad guess. 60 mil, lock it in, and then I can run my pencil along the edge all the way, and I get a parallel line at 60 mil off the edge. Now I can change that to suit any distance up to the length of the blade. So it's called a combination blade also. Also, it will give me an accurate 45. Now, 90 degrees, 45 at 22.5 degrees, which is half of 45 of the most common angles that we use in the trade. Now, there's a 45 angle. So you can see that it's been perfectly cut to 45 degrees. And then you get the corresponding one also at 45, and you get a perfectly square corner. Now that is imperative to get the corners right, especially when you're doing architraves, which is architraves are the outside trim of the doorway, which covers the wall, like the studs, and the edge of the door jamb, and they're always at 45, or should be at 45. Now it's most annoying for the painter when he comes in, or she comes in, and the angle is 44 and there's a big gap at the bottom or at the top. They first have to fill it before they can undercoat and paint. So they won't be very happy with you either, because your workmanship lacks integrity and pride. So if you're going to do something, do it right, preferably the first time. So make the effort to take a little longer, say 2 minutes longer, which will save you hours in repairs or having to do it again. So when we have a 45, also in picture frames, there's a little gadget here called a framing clamp. So I put that in, lock it in, and I put that in and lock it in, And by the time I put it together properly, after I glued it, here I had 4 of these in a picture frame or a mirror frame. Whoop, shouldn't fall out. And you've got a perfectly mitered square corner. These things are an absolute must if you are in the business of framing pictures that people bring of, photos of their family, etc., and they want a frame made up for it. You need a perfectly cut 45-degree angle and 4 of those. So angles are very important in the building industry. Now, if you have a large piece of wood, like a beam, and it gets a bit wide, you've got an extended version of a combination square. So you can draw your line right across the bearer or whatever it is. If you've got a lintel up there that's 250 to 300 mil wide, you can go right across and draw it in to cut it off, rather than having to go halfway that way and then halfway that way. So again, it saves time and it gives you a much better angle. So when I look at this, same with this, for small jobs. If I have a piece of wood only that wide, I don't need a big square which is awkward and heavy, and I just go like that and done. So this is the square family, if you like. This is baby, this is mum, this is dad, this is grandpa, this is uncle. So you've got a whole set of squares that will give you a 90-degree or a 45-degree angle. Now, if you need anything other than those 2 angles, what we use is a bevel. It's called a sliding bevel. That's the position it's stacked in the toolbox. And when you open it up, it slides along the groove there, or the slot. And whatever angle you need, you go up to a job, adjust the angle, tighten it up, and then you go back to your workbench and you transfer the angle onto whatever piece of wood goes up there. So a sliding bevel is just as important as a square, because as I mentioned when I was working at the Opera House, this was my saviour, because all angles there were weird and different. There was nothing that seemed to be same left, same right, because the building, as you know, was very unorthodox. Beautiful building, but everything in it was different. But that's where I learned to cut angles. And if you don't know how to cut a correct angle, you need one of these. Don't guess it. Use this and then draw your line, and you can follow it down. And when you put it in position, whether it's a riser on a staircase or whatever it is, you will know that it's right. If you're going bigger, like you have to put a slab down, say just for a garden shed, say 3 metres by 4 metres, just for somewhere to put your mower and your tools, etc., you want a square slab. Now, how do I do that when this one here is only a limited length? Well, then we have to apply a different rule, a different method. It's called the 3-4-5 method. That means that if you apply 3 and 4 and 5 in a unit, and I'll show you what that means, in the corner you want to build a shed. Right? Now, to get that corner perfectly square, you need to apply what they call the theory of Pythagoras, who was a Greek mathematician. And he said that 3 squared plus 4 squared equals 5 squared. That means that 3 times by 4 times would equal that distance 5. So, if you measure 3 metres and put 2 pegs in the ground, and you measure that way 4 metres and put another peg in the ground, and you move the 2 tapes that you've been using, and you find that this distance from there to there is 5, you've got a perfectly square 90-degree angle. Right? That's his theory, and it works. Right? It works. So, I'll draw this in more visible, or an explanation. 3 squared plus 4 squared equals 5 squared. So we got 3, right? 4 and 5. That's your triangle. Now 3 squared is that. That's 3 times 3. That is 4 times 4. And that, see, get that right, is 5 times 5. So 3 squares, 3 threes are 9, 4 fours are 16, 5 fives, 25. Right, so you got 9 square metres, 16 square metres. Right. So 16 and 9, 25. Plain arithmetic. Now if there are any variances in that, you will find this angle will be either obtuse or acute. That means it'll be either more degrees or less degrees than necessary. Now, when I first started teaching apprentices, they haven't even heard of the 3, 4, 5 method. Never even heard of it. So I went out on the lawn with them. They were armed with tapes, a mallet, a couple of pegs, and we said, right, Joe, you go over there, 3 metres, put a peg in. David, you go that way 4 metres, put a peg in. And then one of the girls would measure from that peg to that peg. If it wasn't 5 metres, we would adjust the peg across or further out. And when the tape measured 5 metres, we knew that this corner was perfectly square. So when you apply that in real life, out on the lawn, out on a job site, if you've got a building, you know, it's probably done with dumpy levels now, because you wouldn't have a tape that long. So it's done from a surveying point of view, but the corners need to be square. And if they're not, well, every other trade that follows through will have problems. And the last one on the roof, you will find they will curse you because the sheet of roofing iron won't fit. It'll run off somewhere because the whole building is out of square. And I have seen that many times. Many times. Because people have no pride in their work, they have no building integrity, and they just do it for the money. And that's what we want to stamp out, folks. We need to restore honour, integrity, and job satisfaction through quality workmanship. So squaring up a job or getting the angles right is just fundamental. If you can't get that right, you know, you're not a true tradie. You're just running on a wind and a prayer. So, I think that sort of covers the need for squareness, and we'll talk about other things like plumb, level, flush, even, parallel, all those sort of elements that make a job perfect.